Hello everybody, today I'll be talking about the moon illusion. I hope you enjoy. What is the moon illusion? The moon illusion is what makes the moon look bigger on the horizon and smaller while looking directly up at the sky. You can see this every day when the moon rises or sets, but in reality it's still the same size. The moon illusion can also work with the sun, but I advise you to not look at the sun as it can damage your eyes. What creates the illusion? You may think that's just light refracting in the atmosphere, but that's not the case, as a photo can clearly show that the moon on the horizon and directly on top of the sky is both the same size. In fact, the moon's size isn't changing at all. It's just our eyes malfunctioning with depth, size, and using shortcuts. This is classified as an optical illusion, just like those same kinds of pictures which look like they're moving even though they're not. What type of optical illusion is it? Scientists still have a difficult time figuring out what kind of optical illusion makes the moon seem larger or smaller, but there are guesses. Some scientists guess it's the Ebbinghaus illusion, where since on the horizon all the tiny trees and buildings make the moon look bigger than it really is. So let's take for these two orange dots for example. One dot is surrounded by big dots, and the other one is surrounded by small dots. You'd think that the one that's surrounded by small dots is bigger than the one that's surrounded by big dots, even though they're the same size. Because, relative to the dots surrounding it, the orange dot on the bottom seems big. But relative to the dots surrounding the orange dot on the top orange dot looks really, really small. But this illusion won't work with the moon, because airline pilots also think that the moon is larger on the horizon while flying, even though there's nothing near the moon as a reference point. Others think that since the moon looks bigger on the horizon, it's because of size constancy, which is how your eyes use depth to approximate something's length. So for example, you have two yellow dots on a railroad, and you see that the one that looks far away but still the same size looks bigger even though they're the same size, and that's because of size constancy, because we know that as something goes further it should be going smaller, but that doesn't work with the moon, so our eyes have trouble and think that the moon is larger on the horizon. So for example, let's talk about the first illusion we talked about. So here we have small trees, relatively small mountains, small looking buildings, and we have the moon, which compared to all the trees and buildings and small mountains, it looks gigantic. And that's why we think this illusion is because of the Ebbinghaus illusion. But again, this is false because airline pilots also see the moon as bigger on the horizon, even though there's no reference points. The second type of illusion. The size constancy illusion might work with the moon illusion because our brains think the moon is super far away while looking on the horizon. But when the moon is directly on top, there are no reference points. So we default to our shortest range for our focus with our eyes, thus making it feel as though the moon looks smaller. So for example, we think and we already know that the moon looks far away while looking at it on the horizon. But whereas here, we don't know how far it is. Our brains cannot comprehend it. So here we think that the moon must be really big. But here, since we don't know the actual height and our brains can't comprehend how far away it is, we default to our small setting and we think it's small. Goodbye, and I hope you liked the video.